In this lesson, we will cover some of the basic sequence data types. They allow to store and organize multiple values in an efficient manner and as such are essential in Python. Our first sequence data type is called list, which is an ordered, mutable collection of items, where each item within a list can be of any data type, including another list. I'll start by showing a list with my most outstanding qualities as an individual. As you can see, lists can be created using square brackets. Moreover, values within the list are split by a comma. You may also use the list function, similar to how we've used previous functions. My recommendation is to use this function when you want to convert another data type into a list. When creating a list from scratch, use the brackets like in the previous example. For example, I can create a list of letters from what my wife insists on calling me. Note that you can convert any object into a list, as long as this object is an iterable. Iterable means it can be looped over, or simply put, it means Python can access each element of an object one by one. In this example, Python goes through each character and stores it in different indexes of the list. Lists and strings are examples of iterables. Booleans, numeric, and none types are not. Previously, I mentioned that lists are ordered. This means you can access a value within the list by stating the index of any position. This index always starts at 0 and goes up until the length of the list minus 1. For example, a list with 3 items has index 0, 1, and 2. For instance, if I want to obtain the first quality in my qualities list, I can type qualities, followed by square brackets, with the first index value, which in this case will be 0. This is called indexing. And what happens when you try to reach for an index that does not exist? In this case, Python will raise an index error for our list, stating that the index is out of range. Note that index 2 is out of range because our list contains 2 items. Thus, we can only access indexes 0 and 1. Lists are also mutable, meaning you can modify the values associated to each index by adding, deleting, or shuffling existing items. When it comes to adding new elements, I want you to be mindful of a couple of operations. First off, you can append values to your list. Appending means that you will add the new object to the next index of the list. Let's say the object here is a list with another 2 qualities. When appending back to the qualities list, you can see that the list is occupying the new index. This means that the different items were not placed in different indexes, but instead they were added as is to the new index. In fact, you can see that the data type of this new index is a list. In order to access my most sought after quality, I would need to access the last index of my outer quality list through index 2, and then go to index 1 of the inner list. This is indeed a lot of work, and there is a better way to add each item of a new list into separate indexes. It's worth to mention again that a list can contain any data structure inside one of its indexes, including another list. That's why we were able to stack multiple index calls in this example when using multiple square brackets in a row. Alright, let's just quickly delete the last index before leveraging a different way of adding items to our list. For this, we use the del keyword, which stands for delete, followed by the index we want to delete, in this case 2. Now we can finally use the method to add each index into separate indexes. This method is called extend. Now you have a better idea on how to add different objects into your lists depending on the use case. Lastly, if you want to replace a specific value in your list and you know which index it occupies, you can simply set the list index to your new value. In this case, I'm setting the first index to a new quality. At this point, I want you to retain the idea that lists are a part of the sequence data types and that they are mutable and ordered. We'll cover a few more operations that are shared across the sequence data types after we learn more about tuples and ranges, which are part of the same family. Good job on finishing this lesson.